Our next topic of conversation is half-lives. A half-life is the length of time that is required for one half of a substance to deteriorate or decay. Half-lives are often used in situations involving radiation. For example, suppose that the chemical glacium, which is a made-up name, has a half-life of 1 week. Suppose further that there are 1,000 grams of glacium today. How much glacium will there be in 1 week, in 2 weeks, or in 3 weeks? Well, we could use first principles on this. In 1 week, there will be 1/2 of what we originally had. 1,000 times a half is 500. A week after that, there will be 1/2 of what there was at the end of the first week. So we simply take the amount that we had at the end of the first week, multiply it by 1/2, and we find out that at the end of the second week, there's 250 grams of glacium. And finally, at the end of the third week, we take this number, multiply it by 1/2, and we have 125 grams of glacium. So we're losing glacium each week, but we're losing the same percentage all the time in each week, but therefore we're losing actually less and less as we go because there's less and less from which it's going to deteriorate. So let's take an example. Let's do an example from scratch. And you might be wondering, is there a formula for this? The answer is yes. Imagine the chemical black barium has a half-life of 45 minutes. Imagine further that there are 6,400 grams of black barium now, and we'd like to know how much there will be in 6 hours. Well, we begin with a prior amount of 6,400 grams. And we make note that the total time in the question is 6 hours, and that 6 hours is equal to 360 minutes. And we note that the length of a half-life is 45 minutes. And we use our formula for half-lives, which is the final amount in a half-life question is going to equal the amount that occurred prior to any deterioration times 0.5 to an exponent. That exponent is going to be the total time divided by the length of a half-life. And we have to, in each one of these questions, make sure that our total time is in the same units of time as our length of our half-life. So our total time in the question was given as 6 hours, but our length of our half-life was 45 minutes. It's up to us to convert 6 hours to 360 minutes so that we can then divide our total time divided by our half-life. So the final amount is equal to the prior amount of 6,400 times 0.5 raised to the exponent 360 divided by 45. Well, 360 divided by 45 equals 8. So our final amount equals 6,400 times 0.5 to the exponent 8. 0.5 to the exponent 8 is 0.00390,625. When we multiply that by 6,400, we get a final answer of 25 grams. So therefore, we can say that there will be 25 grams of black barium in 6 hours under the conditions given. For our next question, imagine that the chemical rockingcharium has a half-life of 40 years. Imagine further that there are 3,750 grams of rockingcharium today, and we would like to know how much there will be in exactly 2 centuries. Well, our first job is to determine how much 2 centuries is in terms of years, because our half-life is given in terms of years. So our total time is 2 centuries, which is 200 years. The length of our half-life is 40 years, so our final amount is going to be the amount prior to any deterioration, 3,750, times 0.5 to the exponent of total time over length of a half-life, which is 200 over 40. That's 0.5 to the exponent 5, which of course is 0.03125. When we multiply that by 3,750, we get approximately 117.2 grams. So therefore, we can say there will be approximately 117.2 grams in exactly 2 centuries.